My name is Leela Pakawong. I'm a project associate with Build It Green, and I will be facilitating today's webinar and any questions that come in throughout. Build It Green is a nonprofit membership-based organization that focuses on providing resources to building professionals, architects, engineers, contractors, design build organizations, realtors, and appraisers, including homeowners who are searching for healthy and resource-efficient building and design. We host a few certification trainings that some of you in the audience may have taken and work hard to supplement those trainings with additional educational opportunities, such as these webinars and a few conferences we hold annually. We often try to present the latest technologies and design techniques to help the discussion for the future of green building. Innovative water conservation and energy efficiency solutions like passive heating, solar water heating, electric charging stations, drain water heat recovery, and living roofs have all begun to take hold in our cities and are making their way to all parts of the state. Homeowners are not only soon to become better educated about resource conservation and energy efficiency, but they will begin to look for properties that reflect these values back to them. This is one of the main reasons why we want to connect our audience members to resources such as Bill Holloway, so that we can provide the best buildings, the healthiest buildings, smartest buildings for our homeowners. Today's presenter is Bill Holloway of PG&E. You'll actually be seeing a live video of him, so I don't know why I put a picture up. Bill Holloway is a senior technical specialist at the PG&E Training Center in Stockton and has been involved with energy efficiency since the 80s. His work focuses on residential energy efficiency, with much of his time dedicated to teaching the PG&E managed low-income weatherization program to contracted employees. His expertise on energy efficiency is directed to residential customers, and he's one of the 4 company instructors who deliver energy efficiency directly to customers as well as students in the PG&E sponsored programs. Bill actually brought a few tools with him that we will take a look at today. This includes a light board with dimmers to show why CFL is not dimmable and LED is, an IR camera, an HRV, a demand water saving device, a few insulation samples, and a smart meter board. As for questions, we have a few options for you in our audience. One option is that you raise your hand throughout the presentation and I'll address you single-handedly through the chat function on GoToWebinar, or you can type in your questions in the question panes for me to read aloud to Bill. With that, I would like to have you guys all join me in welcoming Bill Holloway.
Good afternoon. Stare at the camera. All right, we had a couple of questions came in. So first off, the 3 questions we received are those people online now. Raise your hand. If so, we'll address those first. Give you all something to think about in the meantime.
It looks like actually we did. Doug Smith is on the line.
Which one was Doug's?
Doug, I'm going to chat you. While I'm addressing Doug, how about, Bill, we address how does metering work, which was one of the questions that we received before the presentation.
How does metering work? Well, that's a general question. So specifically, I wonder if it was about the mechanics of a meter rates, your monthly rates, which one it is. So let's address the mechanics first, and let's start with a gas meter. They're very simple. As the gas flows through, they actually measure cubic feet, all right? Even though you're billed in therms, they measure cubic feet, and the general number is 1,000 BTUs per cubic foot, or 100 cubic foot is 1 therm, 100,000 BTUs. There's a multiplier in there for when the gas is a little more than 1,000 BTUs per cubic foot, and there's a multiplier for when it's a little less, so it averages out. But they just move back and forth like this. They have a mechanical mechanism which drives the dials. So it's a very, very simple, very reliable, sometimes they squeak type of meter, and that's all there is to it. Now, electric's a little different and far more complicated, but it does more. These type of meters only give you daily reads, the modern smart meter for gas. That's it. An electric meter, which is probably a little hard to see on the image right now, of course, the old mechanical meters, you would set up, I think it was called an eddy field, but it would sense the electricity flowing through and mechanically spin a wheel, which then turned the dials. With a modern meter, of course, it's all solid. So they're actually more reliable than the old ones in terms of accuracy, which is nice for the utility and everybody else. And these, because they're electronic, can do far more. And I imagine a fair number of you online have already gone on to their PG&E accounts, if you have one, and you checked about how you can see your hourly use with an electric meter. So literally, you can check within 24 hours, that's the delay on the meters, what your usage has been. So if somebody turned on the air conditioning yesterday when it was so hot here in Northern California, you would see it on today's. You would see a jump in the hourly usage. So they're very nice for that. You can go back. Most meters have been in for 3, 4, even 5 years now, 6 years in a few cases. Down south in the valley is when the first ones generally went in. And you can look at your usage historically. So they're great for that. Somebody move in, somebody move out, you added equipment, you added an electric hot tub, you can see the difference in the bill. So all of those are handy ways to use the electric meter. But they are not, neither meter is not a radio. They do not run constantly. Broadcast time is around 45 seconds a day, and that's it. That's total in a 24-hour period. They've got memory in them, so if there's your neighbor parks their motorhome and blocks the signal for 2 weeks, they can remember all that and then download it. So there's quite a few different things. There's even a second channel in these, although it's not really enabled yet, that is supposed to be for smart homes. But apparently there's some protocol issues, so the meter doesn't have that set up in most cases. You cannot get an app for an electric or gas meter to see your online usage, because that would make a radio. Now, you can spend what I understand is several $100s easily and get some additional equipment from a third party, and it goes on the panel, the breaker or the fuse panel, and you can have an app and you can look at your usage that way. Runs through the internet on the house, I suppose. But that isn't what these meters will do. See if that generates any questions while I'm wondering. No. So I nailed everybody's requests on these. One bit of history is that the old mechanical meters, as like so many things, as they age, they run a little slower. So the advantage with these meters is they have a longer period of, like, their entire lifetime of accuracy. So your usage is what it should be. So if you think of any questions later on, we can discuss those. Now, one of the things that relates to meters, of course, and the utility and everybody else in the world is gone on and on about, for some benefit and some not, is lighting. And the problem is that most people only spend, it depends on which study you read, who did it, what kind of hidden agenda they had, and whatever else you can think of. But generally speaking, most customers have only between 5 and 20% of their lighting bill, or their total electric bill is lighting. So it's pretty minor. So you run around and change all the light bulbs, and then you don't see much of a change. That's in a house that doesn't have a lot of light bulbs. Now, I was in a house a while back that had 100 recessed lights, all with 75 or 100-watt floodlights, incandescents in it. And when you turn those on, believe me, you can see them from space. That's not a typical house. And he didn't turn them all on except when he threw a party. And he was running 6,000 watts an hour in that particular case. That's with no air conditioning running. But with standard lighting, this is a fluorescent. This is an LED. And one of the issues is depending on the type of dimmer you have installed in the house, you may have a dimmable fluorescent that will dim properly. You may have an LED that's listed as dimmable, and it may not dim properly. So there's no such thing as a perfect fit on lighting at this point in time. This LED, it's hard to see in the image, but is actually struggling to dim. It's working quite well right now. This fluorescent, however, as we get down, it will strobe. How does it show in the image? Pretty well.
Strobes a little bit, not as clear. In person, the light is strobing.
That's a little. That's
there we go.
The catch is this: that most fluorescents, because the electronics in the base are built to a price, they're not commercial grade. They don't like short run times. Things don't warm up. They don't last as long. We've all had that experience where our 10,000 hour or whatever it is fluorescent light bulb lasted 1,000 hours or 2,000 hours. So even though there's no official rule of thumb, at least not that any of us have discovered, assume that if it's going to be on 10 minutes or longer, that's great. But if you're going to be gone less than 10 minutes from the room, just leave the light on. The operating cost on a fluorescent is really low, so why not? You get the life out of it that way. When we cause the strobing problem like this on a dimmer, we're essentially flipping the light switch on and off very rapidly, or short run times. LEDs that are dimmable, and be careful because you'll get them that aren't, they tend not to have the strobe problem most of the time. But again, it's the type of lamp. This one over here, and I don't want to aim it right at the camera because it's really bright. It's for a floodlight in a ceiling. But if we tip it slightly and I dim it down, it will also strobe. Even though it's rated, it's dimmable. So keep the receipt when you buy them in case they don't work with your dimmer. And this is not a cheap dimmer. This is a $35 dimmer at least. It's a power dimmer. You come in and you touch it and it goes up and down and all these presets and cute stuff. So it's quite complicated. This one, which is going to be very bright on the image, is a commercial screw-in light bulb. These are rare. I borrowed this one from the lighting center in Davis, and they don't know that. This is about a 300-watt light bulb, but it fits in a standard base. So that's about as bright. I don't know where you're ever going to find anything this will fit in, but they do make them. And you don't have to have a big, long 4-foot tube to get that kind of light out of it. So lighting is very simple. If you're going to remodel, go straight to LEDs. The building inspectors love it because they don't have to think about meeting the Title 24 rules, et cetera, et cetera. Just go right to the LEDs. Even though you spend a little more money up front, a typical LED lamp like this one here is going to be 15,000 hours on the low side. Well, that's 50% more than a typical fluorescent, so you're ahead even if it does cost you $15 instead of $8 kind of thing. The LEDs also have color temperature, so you can go ahead and shop around. Remember, 27, 2800 Kelvin, 2800, 2700 K, in other words, is basically an incandescent light bulb. It's not daylight. Daylight's 5300 or higher, depending on how you want to argue lighting patterns. For the lighting architects, this is very critical numbers. We're not going to worry about that today. My kitchen has 3500s in it because them that decided like the whiter light and the yellower light of a 2700, they're all LEDs. So there's choices in those as well as fluorescents, of course. Do we have any questions?
Currently, no questions have come up, but I would just like to remind everyone to use the questions pane or the chat box to be able to submit any questions you have coming up during the presentation.
Well, we had two other questions come up ahead, so we could read either one of those. You want to read one of them?
Yes. One says, I'm an Oakland homeowner and would like to get information about any rebates, tax breaks, or other programs designed to help me afford energy upgrades such as window insulation or appliance and furnace upgrades.
How much money do you want to spend? It's a matter of how far you want to go. Now, here at Building Green, you know, they have all kinds of literature, so does PG&E, on just how far you want to go. But let's keep it on the less extravagant side. So if you have an existing building and it's in Oakland and it's not brand new or anything, one that was built since the '89 fire, we'll assume not that new, then lighting is an easy way to do it. You screw them in, all right? If you're going to remodel, then you get different bases, so you can't put an incandescent in. That makes a big difference, the GU24 or whatever kind of base you're going to use, or the little tiny candelabra bases, the 11s and 12s. But with that kind of lighting, again, it's not going to be huge, although any outdoor lighting that runs a lot, definitely go to LEDs. But in terms of the existing structure, you got to go up in the attic and you have to look. If you want to do a major remodel, then you probably want to go through Energy Upgrade California, EUC. That's where the real money is in terms of rebates. And if you do X amount of dollars, you can get one set of rebates. If you do further than that for the next tier, you can get larger rebates, but you do quite a bit more. There's technical requirements as well. But let's keep it simple. You want to do something like attic insulation. All right, well, you have to bundle it with a few other things. There's no standalones and hasn't been for a few years now. So you can't just insulate your attic and get X amount per square foot. under Energy Upgrade California, you would do that. You would get some diagnostics done. You might do something else. And you would get, $1,000, $1,500, whatever it is, for that bundle of features. I'm not going to go into all of them today. Or you go really nuts. All right, now I have a 1908 house, which we'll refer to again because it's constantly being an experiment, shall we say. And for mine, I would go the further level because it's an old plaster lath house. It has a short crawl space, not a basement. It has a bit of an attic, not much. It's a story and a half, so that makes more issues. 10-foot ceilings downstairs, 9-something upstairs. What would I do with something that old? Well, in a remodel, of course, I'd insulate the walls. And what would I insulate the walls with? Well, there's a lot of choices. There's, of course, good old fiberglass, which gets put in wrong. There's the cotton, this stuff, which costs far more than the fiberglass does, at least in my experience. This is wonderful for do-it-yourselfers. Contractors aren't so fond of it because it takes longer to put it in right. Fiberglass takes a long time to put in right as well, but at least it's a less expensive material. The cotton works every bit as well. It's got the fire retardants and so on. Typical white fiberglass in bats. You can get pink ones, yellow ones, whatever you want. All right, same thing. However, there are a couple of suppliers, one out of Oregon and one out of, I believe it's Reno, that are now producing something that is basically organic. This is wool. It can be wool colored, whitish, or this strange, almost maroon-looking color. But what happens is they import some of it out of New Zealand where they have an excess of wool because most of the sheep are raised for food, not the wool. And they're starting some wool stock up in Oregon to raise the sheep just for the wool. And you can get it as a blow-in, so you can pump it into a wall cavity, which is really nice. I suppose you can blow it into an attic, but it's really designed for wall cavities. Or you can actually get some bats. This is just a piece of one. And again, it meets all the fire retardant rules in the state of California, Bureau of Home Furnishing requirements, and so on and so forth. You can get foam. I didn't bring a piece of foam, but you can get foam. Foam comes in a high density and a low density, and it all depends on your budget and what you really want out of it. And there's advocates of all of these, and there's detractors of all of these. Utility, we don't care. It's up to you to pick which one you like. We don't have a favorite other than my personal preference because then I don't itch with the cotton stuff. But that's only on my own projects. Now, in EUC, other things let's go back to the utility rebates. Utility rebates, there's only a handful of them. There's like a $75 one for a high-end efficiency, not cute, but a highly efficient refrigerator. Water heaters have to hit certain standards, gas, electric, that sort of thing. But there's only a couple of them. Okay, how much are you going to save? Wow, I suppose we could do it on the board. And let's do that. Ready for some math? Let's show you what kind of savings as a percent you would save if you swapped out a gas water heater at X efficiency for a new one at X efficiency. The math is actually pretty simple. So the math works like this. You take the new efficiency minus the old efficiency, divided by the new efficiency, and that gets your percent savings, if you will. So somebody in the room here with me has a calculator handy on their phone. So if you get a new 62% efficient, let's be optimistic, and you get a 65% efficient, which in a low NOx can be pretty tricky. 65% minus the old thing in the garage is probably around 50, 55 on a good day. Let's be honest, it's probably 50 because they're totally neglected. And then we divide by 65. So what we have is 15 divided by 65. So what's our improvement?
23%.
So all things being equal, and thank you, your water heating costs will go down about a quarter. Is that worth replacing your water heater? Well, this is a gas water heater, which is probably costing you all of $15 a month anyway. So saving that to replace, $600 to $800 for a water heater by the time you install it, maybe not. However, in California, only 10% of the water heaters sold or electric. Why? Because we like gas, because it's cheaper to operate in California, and so pay attention. I get that from the trades. So instead, let's try an electric water heater. We don't even have to do this. We're going to do this a little differently. And a standard electric water heater is somewhere in the neighborhood of 95% efficient. And are we going to get into the formula how you figure that? Not a chance. However, if we get a heat pump water heater, and there's a bunch of brands, they're usually somewhere in the neighborhood of about roughly 250% efficient, which is, of course, sounds like a miracle, because how can you have more than 100% efficient? But remember, heat pump water heaters take the heat out of the surrounding air and dump it into it. So if you live somewhere and you've got the water heater in the garage, you put it in the garage, you got an air-conditioned garage in the summertime. All the hot water you possibly want. Now, the winter, the garage gets pretty cold, but you're not living there, so what does it hurt? The big deal here is that in most studies and in, people's looking at their bills when they put in a heat pump water heater, the bill actually went down, bill dropped over half when they went from an electric water heater to a heat pump water heater. That's the real world numbers that have come up. Your mileage will vary. It's worth considering. The nice thing about a heat pump water heater is it plumbs exactly the same electric and water as a as an electric water heater. So there's nothing other than the catch. You have to get lots of air to it. Whether it's garage air with vents in the garage, whether it's in the attic why would you put a water heater in the attic if it ever leaked? But anyway, there are a few. But you just got to get a lot of air supply to it so it can pull the heat out of it. That's all. So if you know anybody that lives somewhere. Now, the other difference is that if you're comparing this to propane, this gets a little tricky where it snows, but if you're comparing this to propane, the drop can be even greater. If you go from a propane water heater to a heat pump water heater, you can have a bigger drop than half even. So that's one big advantage. However, you have to do all the extra electrical plumbing to do that, where, of course, with a propane water heater, there's no issues. Other things that come up. Furnaces. Apparently, the DOE is now asking to move the furnace standard from a proposed 92%, I believe it is, in the northern climes, from an 80% to a 92% of the northern climes, and they're asking for feedback to actually mandate a 92% in the southern climates, which is creating all kinds of fuss and drama, because when you pull out an 80% and you have to put in a 92, there's a lot of extra plumbing involved with the plastic fencing and so on and so forth, and fresh air supplies and whatnot from outside. But there is one formula, if I can remember it correctly, that you can size a furnace. Now, one of the big issues with furnaces, as the utility sees it, is when you replace a furnace, you don't want to put in a bigger furnace, which a lot of contractors do. So you might have a 40 or 50-year-old furnace, 50-year-old not an induced draft, just a plain old furnace, open combustion furnace, which is about 60% efficient, to be perfectly honest. The nameplate data isn't reality. This would be like an AFUE rating, so that's the modern way to rate furnaces. And 60% AF, these are, of course, averages. Well, you're going to put in a new one. Let's say you're going to put in a 90%er, all right, or a 92%, or a 94 if you want to get some kind of rebate. And so we put in a new 94% AFUE again. Well, if this old one, let's keep it easy, if this old one was 80,000 BTU, times 60%, we've got a 48K output. If, however, you've got this one and you put in 80K, what's our output? 72 something. So it's greater than 72,000 BTU, right? Or 72K. something over 72,000 BTUs.
76.
76. You've now vastly oversized the furnace. You've got practically twice the output as you started over here, or 2/3. Now you've got all kinds of problems. So, you know anybody doing this, don't. Now, 10 years ago, most contractors had no clue about this formula. My experience nowadays, half of them do at least. So this is oversized. So what you want to do is put in a furnace that gives you this output. We're assuming this worked, all right, in terms of comfort levels and so on. And there's no big addition stuck on the house. So we'll want to put this much out. So what you do is you take the old input times old efficiency, need a longer arm, divide that by the new efficiency, and you wind up with, changing sides, the new input. So if we take the old and multiply it, so what we have here is we had 80K. 80K times 0.60, which is our efficiency, and we divide that by 0.94, we should get a new input of around 51,000? Mm-hmm. Well, that's vastly smaller than 80,000. And remember, you pay for the input. So, if we multiply this number times our new efficiency, we'll get an output of about 48K, close to it anyway. And a few thousand BTUs either way isn't a big deal. So this is the correct way to resize a furnace when you're pulling it out. And of course, you could plug in an 80% here, which is a commodity-priced furnace. One of these is going to cost you considerably more, and it may be a lot harder to put in. With an 80%er, you can use all the old venting, assuming it isn't going into an old brick chimney anyway, and go from there. You're still going to get a savings, of course, because the worst you can buy now is 80%. But go for it. Put the 94 or the 96. I hear there's 97s if you want to write a big enough check. Or get a multi-speed. On low, they're really nice. They're almost invisible in terms of sound. You can't really hear them much, and there's significant savings. However, this rating doesn't take that ability into it. It's only on high.
Great.
All right. So we've covered a bunch of points, trying to get you to ask some questions. Is there anybody there?
We do have one question going back to insulation before I address Doug's question.
Okay.
Which is, what is a good way to seal the crawl space from habitable space? What's a good way to seal the crawl space from habitable space?
How do you seal the crawl space so you don't use the chimney effect of the bypasses inside the house construction? It's called a whole lot of grunt work, and you're going to get dirty, and there's bound to be things under the house that bang on you, if nothing else, old bits of concrete from when they made the place, or petrified cat poop, or whatever happens to be down there. However, what you really are going to use is a bunch of little thin bits of plywood or foil or anything that's airtight. Doesn't really matter much. And you can foam it, you can staple it, and what you're looking for is all the plumbing cuts. That's the first place you look. Usually under the tub, there's a great big one because of the trap and so on. And you would fill in around that. You could foam it closed. You could do any number of things. All right. In terms of the walls, which can act like chimneys, well, that gets a little more complicated. Now, we're not trying to make it a sealed crawl space at this point. Let's avoid that. Let's just say that you want to keep the house from acting as a chimney. So you're going to do the plumbing cuts. You're going to find where the wiring goes into the walls, and you're going to foam all of those closed. You're going to crawl along the perimeter of the foundation. Maybe you get to walk, and simply put, if it's a platform construction, there isn't much you can do. You can spray some foam in there, I guess. If it's a balloon frame, now you have to seal every one of the gaps in the walls between the studs. And you can foam, you use a lot of foam, get a great big can with the high expansion foam. You could stuff some fiberglass or anything else you want in there and then foam over it. You could take little bits of wood and cut them and tack them in there somehow and use some foam to fill up the gaps so your carpentry doesn't have to be all that accurate. But that's where you're going to start with either any internal building chases. Maybe there's a chimney that starts in the basement and crawls up through there, or any plumbing cuts.
Great. Thank you.
It's no fun to do. Fiberglass, any insulation you put down there short of foam won't seal, so don't depend on that. Insulation other than foam doesn't stop airflow. It just slows it down and acts as a dust catcher. What was the other question?
The other question is regarding roofs. So cool roof versus standard roof with rigid foam. If my house has an R38 attic insulation and is air sealed, which is more cost-effective roof replacement, a cool roof or a standard roof with shingles over polyso/rigid foam?
First off, let's clarify. We don't know where the house is. We don't know the climate zone. We don't know if they're out in Mojave or they're up at Lake Tahoe or Shasta or somewhere in between, or down the block from here in Oakland. Let's assume they're not in the valley and the house doesn't have any air conditioning load. In that case, R38 in the attic's fine. The question did say it was already a sealed attic for air passages. Stop. I mean, if you want to throw some more insulation in there, fine. But why go any further? It's all a lot of work, and the payback's going to be very small. Now, if you have heating ducts up in the attic, or cooling ducts, AC, heating, whatever, there's duct work up there, then what you really should do is get a duct test and seal done on the job. There's a lot of contractors who do that now. And that would be anybody's in the trades first call, because there's no point in doing any more work in the attic until you make sure you're not accidentally heating or cooling the attic with duct loops. So you're there. Your duct work is tight, or tight enough. And you have AC loads. All right, if there's ductwork in the attic and you have AC loads, now you have this problem. Let's start over here. You have, and does this show up okay on the screen? A lot of radiant load from the sun. You've got ductwork up here in the attic, and it's going off wherever it's going to go off to, and so on. Most of the load on that ductwork, insulated or not, insulated's better, of course, right, is actually radiant heat off the roof deck. That's 80% of the heat load on the ductwork. The other 20% is the air load in here. That's according to some studies from a few years back. So, yeah, you can have lots of venting, but you're only going to address roughly 20% of the heat load on your ductwork. So, if you have serious issues, you want to kill what's coming off the roof deck. You can buy all those different brands of foil bubble wrap. It's expensive stuff. It works if you use it right, and I'll explain that. You can go to Costco or Walmart, there I haven't given anybody a free plug, and buy the really heavy-duty commercial-grade aluminum foil. That will also work for this. If you're re-roofing, that's another discussion. We'll go to that. And what happens is on your roof deck here, you've got the rafters that come down this way, and you just add it as a layer right across the rafter end, so that as the rafters go, if we draw the rafters this way, you're just going across it with your radiant barrier. You can leave the space behind the rafter. Doesn't matter. And it doesn't have to be perfect. Just some. Now, if this is the north side, then you wasted your effort. But on the east, you get some savings. West, you certainly get some savings. And the south, of course, gets all the abuse. So that's what you want. So if we assume this is the south side here, well, can't do that. The sun's in the wrong place. So if we assume this is the south side here, then you would put your radiant barrier right here, like this. And what happens, without getting into too much buzzwords, is essentially the heat's going back this way. It adds some temperature to the roof deck, not enough to avoid the warranty according to the manufacturers, the last time any of us checked. And you now have much smaller radiant heat load. So if you crawled up in this attic after this was in there, you would feel quite different. No fun working in an attic, at least, but it won't be as miserable. So that's how I would suggest it gets done. You could put foam insulation in here between the rafters, but that's even more work. And it depends on what you're trying to do. Now, if you anticipate eventually making this a living space, any kind of foam insulation up there has to have a fire barrier on it, like sheetrock, you know, 1/2 inch or 3/4, whatever the code calls for. And that would be the next thing you'd have to do. So you got even more work, but it does finish the attic. So, okay, that's ways to reduce this. If you don't have all this ductwork and AC loads and stuff like that, and it's already a sealed attic for the bypasses around all the junction boxes and recessed lights and whatever else, throw some more insulation in there and be done with it. Yes?
What if you have a flat roof with no attic space? What's the best way to insulate?
That's what you're up against, a big cost. The best way, maybe the only way, although moving might be an option, making jokes of this, but if you've got a flat roof, and let's make it a standard design in that it's not a beam ceiling below, although the same difference in this case, we would just skip the bottom layer. But you have a flat roof. A couple of things that can be done. You can drill holes in it from the bottom, not the top, and you blow in insulation. That's fine. You don't worry about the attic venting anymore at this point. And you blow in insulation. You can do that. If, however, you don't have a lower surface, you know, whatever it happens to be made out of, probably sheetrock, maybe, probably not plaster lath, but something, tongue and groove, and you don't have this layer, now all you can do is put taller trim boards around the edge, because it's usually what's there, some sort of parapet of 1 inch or 2. And you put foam board in here. You can put a foam roof on. You hear those guys advertising on the radio all the time. You can put a foam roof. Some of the foam roofs get a top layer, and you can walk on them. I've seen those. Those are nice. All right. It's all a matter of what your budget allows and the exact difference here. If there's a very slight pitch to the roof, a foam roof can be a little tricky as a liquid foam roof because it wants to move. But the foam board goes here, and then you have to put a layer on top of it to walk on it, to protect it, whatever it happens to be. And then your trim boards have to be that much higher. However, your comfort levels, it goes way up.
What about cathedral ceilings with no attic space?
Well, you can't use a liquid foam. We know that. And a cathedral ceiling implies the fact that you don't have anywhere you can blow the insulation because you're looking at the underside of the roof deck, usually a tongue and groove type of thing. The ski chalet you bought, where you inherited and then you discovered it has electric heat, and it's bankruptcy when you tried to heat it the first time. That's not unusual. Now you know why they charge so much to rent a ski cabin with electric heat. We have the exact same issue here with a cathedral ceiling, meaning a pitched roof. The foam board is about all you can do. And I would put it on the outside, so the new roofing surface was there, so you didn't lose the effect inside. Now, if you've got rafters coming up, and you don't mind losing the beam effect of a cathedral ceiling, then you can put foam board underneath and then cover it with your wallboard or whatever you want to use.
Okay.
Now, one of the earlier question was, or the question about Oakland was polyisosanurate board. Right. Polyiso is what the short term for that. Polyisosanurate is about as good as it gets for insulation. However, most forms of it aren't real tolerant of moisture. They have a foil barrier on it for various reasons and so on. It ain't real cheap. It's kind of a pain to cut. You have to frequently, depending on the exact design, work with the right protection, not a dust mask, but better, so on and so forth. It works great. But remember, if you're cutting it to fit in unusual spaces, you have to cut it really closely. It's not something you do with a knife, right? You have to have a better saw than that. Instead, if you have the option, let's go back to our ski chalet, our cathedral ceiling. The polyiso can be par7, par8 per inch, maybe a bit better nowadays. All right, and you would put boards of it up there. We'll exaggerate a bit, and you put the boards up here, and then you have to cover it up with, you know, plywood or whatever it is. All right, and then put the shingles on it. But again, we have those moisture issues and so on and so forth, and you can dent this stuff fairly easy. Instead of polyiso, instead, just use, like, what's the brand name, the Tram product or whatever it is. Everybody makes a color, the blue board. This is our 8-ish per inch. Somebody watching probably knows the exact number. All right, but the rigid polystyrene, D-Y-R-E-N-E or something like that. Polystyrene is about R5 per inch. So if you want to get what this does, you just buy it in thicker boards. But if you've ever been to a marina, one of the ways they float all the docks to go up and down with the tide or in the valley, with the tides in the delta, is they just use big blocks of polystyrene. This stuff is indestructible practically. It's just a thicker version of this. Blue board is the most common one we're used to, but it comes in, pick a color. I see yellow and green and white and orange and red and everything else. And use that up there. It's just a little easier to work with, a little easier to cut, and certainly cheaper. And you don't have to worry about moisture issues and so on and so forth.
Someone in our audience let us know that polyiso's R value 6.
6? Ah. So if we go from a 5 to a 6, that's hardly worth the effort.
Blue board is a 5 and polystyrene is a 4.
Yep. Okay.
Perfect. We have a question. So you talked a lot about home upgrade and doing larger energy retrofits. But what if a homeowner wants to do smaller things and they've heard of smart strips before and they kind of want to know the comparison between smart strips and power strips?
A smart strip is one that is certainly applicable if, and only if, you can put lots of vampire loads on it that you don't care about, that you can turn off. Now let's clarify. A vampire load is anything that's on all the time, whether you know it or not. Your thermostat is a vampire load. The one for your central heating and cooling system is actually a vampire. All right? And if it's a newer system, it's 5 watts. If it's an old system, it's more like 25 watts. Right? Your DVR, your TiVo, your digital video recorder, well, it depends, but frequently they're somewhere between 20 and 40 watts. They're supposed to be making them more efficient. I haven't seen one yet. Maybe next week. That's a vampire load. Any clock you have plugged in, the one in the microwave, the one in the oven, those are all vampires. Your fish tank is a vampire because of the pump. Not because the lights turn on and off because the pump runs constantly or whatever. A fish tank with a heater, all right, the tropical fish with a heater. The heaters by the industry spec run half the time. So you can take your heater, which is sized at 5 watts per gallon. So it's a 10-gallon tank. It's a 50-watt heater. That's a 25-watt vampire load, 24/7. When you start walking around a house and adding those up, depending on what all's in the house, it could be quite something. I've been in houses that had 3, 4 DVRs. The old-fashioned cable boxes were good 20, 25 watts. The kinds with the wood grain finish. So what was the question again?
I think you answered it, actually. It was just a comparison between smart strips and power strips.
Well, a smart strip is supposed to work like this. Now, there's takeoffs on this. I'm going to keep it generic. And what we have here is you'll have a master plug, and then you'll have dependent plugs, whatever you want to call them. And so when the master load goes off, all of these go off. These all turn off as well. Off, off, off. These over here are hot all the time, just like any power strip is. Hot 24/7. So if you could plug your DVR into the 24/7 side, so you don't lose the programming ability, you plug your TV into the master, and then you put the sound system or the DVD player or whatever else you have into this side. So when this goes off, the power strip shuts all these off. One of the things that's come up, however, is some units, computer printers are a good one, when this shuts it off, so your computer go here, your monitor or whatnot goes here, sometimes you have to manually turn it back on again. They don't automatically power up. So it depends on the design of the start-stop switch. But that's a smart strip. Is there a rule about how many watts? No, not really. I suppose we could reverse engineer something and say if the watts was this, but it all depends on what you spend on this thing to get your money back. There you go. Some people just put everything on a plain old smart strip, a power strip, this side, and they just leave it at that and they just turn it on. That's fine. Whatever works for you. That's a smart strip.
Great. Thank you, Bill. So what I'm going to say now is that we're actually going to leave it open for any last-minute questions that come in, but we have about 7 minutes remaining in this webinar. So, Bill, I'm going to take you off camera.
Okay.
After the conclusion of this webinar, we're going to ask everyone to take a moment to fill out a short survey that will help us kind of project what our next webinar topics should be, maybe what trainings we should do. Your feedback is very important to us. This webinar, for participating the entire hour, you'll receive one Build It Green CEU towards your next recertification. And you can do that by submitting it to this link here. You can also find this link on our Build It Green website under recertification. Today's presenter, Bill Holloway, just want to thank him for taking the time to come into our office, bringing all this great equipment for us to look at and providing great insight into energy efficiency. This is his picture in case you forgot for some reason, and his email. So if you have any questions that you do want to ask him one-on-one, please feel free to email him. You also have the option to email Build It Green, and that's training@builditgreen.org. And we can direct any questions to Bill if necessary. He's laughing at his own picture now. Again, I would just like to thank everyone for joining us today. We look forward to seeing you at the next webinar. And additionally, I would just love to thank Bill for coming and joining us. Thank you, Bill.
You're welcome.
Have a good day, everyone. We'll see you next time.